Can I process? Can I proceed, sir?
Yeah. Yes, sir. Proceed, sir.
Okay. The weights of that BLST model we represented here the W. The another network model, artificial neural network, weights will be represented here WE. Select those weights are we have to another network model, artificial neural network, weights will be represented here WE. Select those weights are we have to fine tune those weights using this algorithm BRC scheme. The below table describes what are the hyperparameters, how the hyperparameters can be tuned for the classification purpose. These are the different network model, artificial neural networks, BiLSTM, BiGRU algorithm, as well as a supported vector machine model. See, what are the different layers I'm using here? Dense layers is 100. The activation function is relative activation functions. So inner layers are the 2, the size will be the 3, and the optimization activation functions, softmax activations. The loss is sparse category cross matrizer, and optimizer is RMS propagation optimizer for the ANN. BiLSTM is for the same layers I'm using for that all, but the filter size will be the varies. For the filter size for the BiLSTM, I use a 128 activation function. It is BiLSTM activation function suitable for sigmoid, and the loss is for the same sparse category cross entropy, and optimizer is here RMS propagation, but here since we filter size is more, so that we were using that add a normal gradient descent optimizer. We have to use BiGRU. If it is a BiGRU, the filter size will be the 64, activation is relative, the rest of the things will be the come, as well as support vector mission, the C will be the 0.03, the kernel size is the linear kernel. These are some of the few parameters for classification of all the network model. And we combine this BOA as well as a BRO to form the BRC BOA. So butterfly object optimization algorithm as well as Boyer's Royal optimization. Finally, we form these two algorithms, optimization algorithm. We merge it as a one hybrid algorithm, name it as a BRC BOM algorithm. So it is impacted by how butterflies scavenges as well as a mate. It will be happen in the 3 phases. One is initialization phase, iteration phase, as well as termination phase. In the initialization phase, the constraint solution space and the objects are specified. In iteration phase, we use the two different schemes. One is a local as well as a global searching for deploying the iterations, how many iterations will be happen. And while coming to the termination phase, BOA terminates when the utmost iteration is reached. And this is an algorithm. Initially, we have to initialize how many number of the populations, that is for n number of the butterflies. Then we have to calculate that fitness values by intensity values for each butterfly. We calculate for the fitness, and the sensitivity we have to calculate, that is we terminate as a S, that is modality. Then power exponent we terminate as alpha, and the switching probability we represent for that P. So we take a one while loop. We have to check that entire this loop within whenever the stopping criteria will be does not meeting for that one. And inside we'll take each and every population for that all the population from take one butterfly. You have to calculate the set for that butterfly using the formula Q equal to SL power alpha. So for all the butterflies in that enter the population, we have to calculate it. From that center, we need to find out that best butterfly for that one. For calculating the best butterfly from that population, first we have to consider one arbitrary integer. For that arbitrary integer, we name it as R. For check that arbitrary, this is arbitrary integer is R. That is what is probability? Probability it is less than. We have to switch for that. That is a butterfly by solution, the best butterfly by solution. Otherwise, the butterfly is a random butterfly. So after that end, we have to apply our new proposed method called as a Libby flight concept. We have to apply. So we have to continue this loop entire all that populations, and finally we have to update for that alpha. Then finally we have to end the while loop. So whatever the output we will get, that is a dynamically, we have to represent that is a butterfly, the best solution. The table will, some parameters I introduced for that one. I said that no, S equal to, normally we have to take the S equal to 0.01, the probability. Initially we considered 80%. The alpha we have to reach as the parameter 0.1 as well as 0.2. If it is a BRO, the threshold is 3. And if it is a AO algorithm, these are the parameters, and Firefly algorithm. So we implemented BOBR's algorithm based upon all these type of optimization algorithms. While coming for the results as well as a discussion, so we implemented here using a Python for executing the better result for that skin cancer detection. We proposed here BRCPOA method for examine over that conventional methods like BOA butterfly optimization method, battle royal optimization